Welcome to qnawire.
So here we're looking at acetylsalicylic acid, which is also just called aspirin. We're looking at how many pi bonds and how many sigma bonds there are, and then we're expected to know a little bit about free rotation, which we'll handle at the end. So the pi bonds are the easiest part. You just have to count all the double bonds once. So that's 1, 2, 3, 4, 5. For sigma bonds, it's a little bit more difficult. We need to count all the single bonds once. All the double bonds only count for one, they don't count double. That's because a double bond is one sigma and one pi bond. And also, some of the bonds to hydrogen aren't shown. So anytime you see a hydrogen, you know it's a sigma bond. They can only form one bond, so it has to be sigma. So anytime you see a hydrogen, you can also just add a sigma bond. So I'll start at the top here. That's 1, 2, and then 3 for the hydrogen, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 3 more hydrogens will make that 21. So now, knowing which parts of the molecule are free to rotate and which parts are rigid comes down to knowing something about double bonds and single bonds. So since single bonds are head-on bonds, when they spin around each other, they don't change the energy of that bond. So if they're at room temperature, or really anything above 0 degrees Kelvin, they have enough energy that they can spin. However, double bonds have that sigma connection, but they also have a pi bond. And since those are side to side, when you spin them, less of the orbitals overlap. They go more perpendicular. And because of that, their energy actually changes. So it takes a lot of energy to spin a double bond. In fact, it takes as much energy as it does to break that double bond. So anytime you see a double bond, that area is rigid. So this whole ring here of 3 double bonds and 3 single bonds is going to be solid. But this little piece here, this carbon with his 2 oxygen friends, he can spin around. And likewise, these guys can all spin here. You couldn't really tell if this oxygen here was spinning or not because it doesn't have anything on it to tell if he's spinning around. So these two, this group here and this group here are free to rotate, but the central ring here is rigid.